Welcome to Applied Calculus. We're going to begin talking about some of the basics, the XY or Cartesian coordinate system, and then locating points and things like slopes and equations of lines. So what I've done is gone into the media library in the MyMathLab course, and I can bring up the slopes and equations of lines interactive figure. Now I'll talk a little bit about using these figures. These are in something called a CDF format, and you can go to Wolfram Alpha or Wolfram.com or search Wolfram CDF, and there's a player that you can download and allow you to interact with these figures. So what it is sort of an interactive image where you can change components. So for example, you can click points and move, and we'll get into that shortly. Now this layout, this figure where you have a vertical axis, which we call the y-axis, and a horizontal axis called the x-axis, is known as either the xy plane, or the more formal name is the Cartesian coordinate system. You can see that they intersect at the point where it's 0 on both the y number line and the x number line. So this is called the origin. And then it steps off in units of 1 in most cases. So 1 through 8 is listed here. Counting backwards would be -1, -2, and so on. Same thing with the y. The positive numbers go towards the top, and the negative numbers go towards the bottom. And then when we want to locate a point, such as this one, you give the x coordinate first, so that would be at -5, and then the y coordinate second, that would be at -3. Now for the other point, to get to that, we have to go 2 units onto the x-axis and then up in the positive direction 6 units. So we would call that the location 2, 6. We can also move these things around. So if I move it over here, then I'm at the point 5, 2. If I move this up here, then I'm at -5 for the x, +5 for the y, and so on. So we'll just move these points to a couple of new points here. Let's go ahead and move this in some. There we go. Now, one of the other things we want to do is we want to talk about things like the slope and intercepts of a line. Now, we've already defined that a point consists of 2 numbers, an x coordinate and a y coordinate. So for example, here we would say this point has an x coordinate of 2 and a y coordinate of 3. Now, if we want to talk about intercepts, intercepts are where a line would cross the axis. And notice this one looks like it's going through the origin. And that's not necessarily what has to occur. We can take points, and I'm going to move these, and I'm going to start with one where we've got both positive x and y values. So now you can see that the line does not go through the origin. So in this case, we have one point at 7, 6, the other point at 4, 2. Now, the slope of a line tells how steep a line is. Notice that as I move one of these points around, the steepness of the line changes, and it even can go to decreasing as you read left to right. It can be horizontal. Of course, it can be vertical, or anything in between. So we'll go back to the points 3, 2, and 7, 6 and talk a little bit about the slope. Now the slope is an indication of how quickly the y value changes in terms of a unit change in x. And you may have seen it drawn as a triangle, and then we talk about the rise, which is the change in the y coordinates over the run, or so on. So if we click on slope, we can see this one says the slope is 1. Now how did they get that? Well, if you, whoops, let me go back to my point. So how did they calculate the slope? Well, the slope formula, if you look, is the difference in the y values over the difference in the x values, or the rise over the run. The rise is the vertical change between the 2 points, which is the difference in the y coordinates, over the run, which is the difference in the x coordinates. You have to define one of the points as the first point and the other as the second. So let's say that 7, 6 is the first point and 3, 2 is the second point. So then I would take the second numbers. So y2 would be this 2 minus y1 would be 6. So that would be -4. x2 would be the x coordinate for the second point, which was 3, minus the x coordinate for the first point, which was 7. Well, 3 minus 7 is also -4. So -4 in the numerator divided by -4 in the denominator gives a slope of +1. What if we change to a horizontal line? Well, now what you see is that the y coordinates, 6 minus 6, let's take 7, 6 as the second point and 2, 6 as the first point this time. Well, then you have 6 minus 6 as the numerator, so that's 0. 7 minus 2, or 5, as the denominator. So 0 divided by 5 would be 0. What about a vertical line? Okay, well, we say that's not defined. Now, why is it not defined? Well, let's think about our formula. We would take the difference in the y. So again, let's call 7, 6 the second point, 7, 2 the first point. So 6 minus 2 for the y's would be 4, but look at the denominator. 7 minus 7 would be 0. And division by 0 is undefined, so anytime you have a vertical line, we say that the slope is not defined. It's not 0, and it's not that it doesn't necessarily exist, but it's not defined because of that division by 0 in the denominator. Well, what if you had points that are more spread out? For example, like this. Well, again, define one of the points as the first point and the other one as the second. So let's take -3, -5 as the first point, 7, 6 as the second point. So the difference or change in y's, okay, so the triangle, okay, is delta y, and that just means change in the y's. So 6 minus -5. Okay, so that's like 6 plus 5, so that would be 11 for your numerator. And for the x coordinates, 7 minus -3 would be like 7 plus 3 is 10. And 11 divided by 10 is 1.1 in this case. So that is how we define the slope. Now, what the slope does is it says, okay, if x increases by 1 unit, then y is going to, since it's positive, increase by this amount, 1.1 units. Let's drag this point so that we have a negative slope. So in this case, we have a negative 0.222 slope, approximated as a decimal, or -2/9. So we'll go with the fraction. So what this means is every time x increases by 1 unit, then y is going to decrease, since it's negative, by 2/9, or as a decimal, about 0.222 units. So keep in mind that as we're talking about the Cartesian coordinate system and locating points, what we can do is define what line passes through any 2 points. Now, part of that line is the slope, but we also need to talk about where is the line sort of anchored down and stuff. So there's a couple of ways you can do this. One is by using a point slope form of the line. The other one is called the y-intercept, or the intercept formula. So there's a couple of different ways that you can define equations of lines that we can talk about. There's the point slope, and then there's the intercept slope form of the line. So make sure that in chapter 1, as you're reading, you distinguish between the two equations. So if you look at the equation, and there's our slope, -2/9 showing up. So what this does is it goes back and it says, okay, well, the slope tells as x changes what happens to y, but it's anchored down sort of to the y-axis by this other number. So let's get another equation where, let's see, where we have the slope of 1, remember. So what this does is it anchors the line to this -1, so that's where the -1 is here, and then the slope was 1, so every time x increases by 1, y increases by 1. So what the equation is telling you is that y equals the slope, which we call m, times x, and that says just as you change this point, okay, along this line, what is going to happen to where your y value is, and then -1 is where the line is tied down on this axis. Now if you click on the other thing, the values will tell you how they got the delta y and delta x numbers. Okay, so I'm going to take that back off so it's not as crowded. If you look at a horizontal line, now keep in mind a horizontal line has what slope? It has a 0 slope. Notice that x can change. You can be anywhere along the blue line, and in terms of that, you're changing the x values. So for example, I can pull this back here. Notice the x value is -4 in this point, and the x value is +8 in this point. But notice the y value is constant. It's the same. So all we really need to do to define this line is say y equals 2. And really y doesn't depend on x because the slope is 0. If, however, y does depend on x, then you get this multiplier term that says as you move over a certain number of x units, you're going to move up, in this case, since it's positive, a certain number of y units. And then what about a vertical line? Well, a vertical line, remember, the slope is not defined. And really, using the same logic as we did before with the horizontal line, the y value can change, but notice the x value is staying 8 regardless. So in this case, for a vertical line, what we do is we say x equals 8 to define a vertical line. So this is the intercept form of the line, and what I'm going to do is try to keep the video short, so I'm going to stop here for now and then come back and talk about how to find equations of lines given 2 points.